out that it's not just the university, it's actually supported by Statoil as well, Maritime Robotics and Radio Nor Communications. Radio Nor has amazing communications, 300-kilometer range, and Maritime Robotics has been operating the unmanned aircraft for them in their tests to date. So 4 doctoral students on that now, 15 coming this September, and 1 postdoc. So as I mentioned, we all have worked with William Euchre, who's a great Navy lieutenant. He's on a submarine now under the Arctic, and he did his PhD at Cambridge, and I sort of helped set that up with SpaceQuest and got him the AIS data. So this was the data that Paul was talking about. Those are all the monthly ice on that side and ships on this side. I think this is a closer picture that shows for 1 year all where the ship traffic was in the Arctic, within the Arctic Circle. So you can see most of it is over by Norway. And that's one of the reasons I think the Norwegians are interested in getting the unmanned aircraft detection system going. This is the other slide that Paul Berkman and Christina also showed. This is the high seas area of the Arctic right now. These divisions here are the habitat divisions. So there was previously an Arctic marine shipping assessment, and that's kind of what you got here. And we didn't think that that was very good, so that's why we worked with AIS. That took years to make, so that we could get this daily update. And so you can see where the ships are, and oh, I forgot to say, so this is also in terms of fishing vessel days. So it actually tells you by color, if you go down to details, who's fishing, and you can also break it up by country. So I wanted to talk very briefly about some of the things that are going on up there in terms of climate change and what we need to better understand. So capelin basically have their spawning areas here. I picked them because they're sort of at the bottom of the smallest fish that's eaten by the other fish, by the cod, and some of the other fish up there. So the first thing is they have a very high interannual variability. So you don't really know how many you're going to get from 1 year to the next. They almost completely collapsed in the 70s. The fishing stock was closed for 5 years. It was reopened. They had a very large take last year, and they're very happy. But this year, they had to cut the quota 90%. So these sorts of huge variations are typical of things in the Arctic. It happens for many species. So there are still some conflicts among the countries up there over who's getting what quota and how those are being traded. And I will point out to you that the IUU cases in Norway were the last U. They were unreported. So that they were ships, when they boarded the ships, they found out they had twice as much fish as they were supposed to have in the hull. And that's a difficult thing for us to work on. Without actually boarding the ship, you can have all the unmanned surveillance you want, but you're still going to have a hard time actually figuring that out. And one other thing I wanted to point out that's sort of an issue of concern is, if this water warms up, where are they going to go? There's no more north there. And so there's a big concern about not just the effect of ocean acidification, but what happens if it really does get warm? They can only spawn in certain areas, and there's no more areas other than Svalbard up there north of that. So this is, again, if you think that, so I'm supposed to be talking about how the illegal fishing in the Arctic, that's one of our Admiral's priorities. If you think you can just go do it in the summertime, guess again. There are people fishing up there pretty much year-round, and we have the data to show that. We also had NOAA go up and do some surveys in the Beaufort Sea in 2008, and they used these giant Bering Sea trawl nets, and they hadn't been up there in 30 years, and those were kind of pristine areas, and so there was a little bit of unhappiness of the fact that they had just trawled across the pristine seafloor and lost 5 nets worth more than $250,000. So we had a little bit of discussion with them about that and reminded them that there were these things called video cameras and that there were also nets that don't have to be towed on the bottom. 98% of what they got was seafloor, not fish. So we've gotten them, we had a special seminar on non-trawl fisheries research methods and got them some religion. So this is the whale ship collision avoidance thing. You can see the wave glider here. I don't have a picture with the hydrophones, but I think that was shown the other day. So the problem that we have here is that unlike the Atlantic side, our whales don't make noise most of the time, especially the bowhead whales in the Arctic. But you can detect them as an acoustic shadow, where there isn't any noise. It's just like, you know, if you're outside, you hear the wind blowing through the trees. You don't hear that in here. So this is an acoustic shadow. This method has been demonstrated, and this is what's in use by the Canadian Neptune system. And the reason that I should add, the reason we're concerned about this is the United States is talking about putting in another port north of the Arctic Circle in Alaska. and there's some other infrastructure issues. We have 15,000 whales going by there twice a year, so right in front of the port. So we're going to have a lot of collisions if we don't deal with this issue. This is the partnership with Google and Monterey Bay Aquarium. We wanted to be able to measure ocean acidification using a remotely operated system. Francisco Chavez has a great system that he and colleagues at MBARI have developed. And so we were able to get the wave glider to have this measuring system in addition to doing the listening capabilities for the whales. And so I've been focused the last few years mostly on unmanned aircraft operations. This is the Raven unmanned aircraft. We got a bunch of those, 128, coming back from Afghanistan to the University of Alaska. I didn't quite get the hyperspectral imaging system. It got there one day too late in Barrow. But this is infrared, so you can see the ice ridges are what really stop ships. It's not ice per se. And ice ridging is what I was keen to measure. We also did, working with the Canadians, deployed an underwater mapping system on an AUV. And so it was useful for recording those. And you can see over here, we did actually do some seal work too. And that's the Scan Eagle launcher there. So let's see, and then this is just a similar picture that shows, this is what I wanted to point out here. So there's a picture of our ship, and you can see the ice ridges here in white and infrared. What I wanted to point out is, this is the highest resolution satellite map you can get of sea ice. And this green line was supposed to be the ship track. You can see the red is the actual ship track. So the ability to have really good high resolution ice ridge imaging, this was all this moving around was trying to get around the ice ridges, because we don't like going through the ice ridges. They do stop ships, including mine, and it burns a ton of fuel. So we got this COA from FAA to operate. It's the largest COA ever granted, and that's how we did these flights in the Arctic, and not a problem. So